Can you see my PowerPoint slide for chapter 1? It says CHEM 105 fall to 2023. Can you see? Can you see the chapter 1?
Yes.
Okay, that's great. There's a little problem with the sound. I don't hear you very good. Let me see whether I can do something about that. The sound is full, but can you hear me?
Yes.
Okay. In the last class period, we went over few slides. You can go back and watch them. All right. I am going to continue with where I stopped last time and go from there. Okay. Can you hear me?
Yes.
All right. Okay. Last time I went over chemistry and study of matter. We talked about chemistry and chemical change, physical change, and details about little more detail about chemistry. Today I am going to start with, we talked about introduction to chapter 1 and talk about chemistry, how we study matter, chemical changes and physical changes, scientific method. We talked about it. And I told you why measurement is important to scientific method. Observations are the first step in the scientific method. So we're going to look into observation, which include measurements in detail. Now, a measurement could be quantitative or qualitative or quantitative. Qualitative is just a statement. This car is faster than the other. Quantitative means this car travels 5 miles, other car travels 10 miles. So measurement have a number and unit. There are 6 base units in the metric system. We talked about that. Important part of the measurement is number. Number is expressed in scientific notation to make it easier to deal with large numbers and small numbers. We go over it. Now, you should be able to convert scientific notation to normal form. You move the decimal place. So we talked about that. Okay, we are going to scientific notation. We're done with some chemistry and matter, all right? Okay, you need to write down normal number in normal form and scientific notation. Scientific notation is you round out the decimal place with after first place and write down the correct significant figures and have exponent notation. Okay, this is the questions, answers, or choices. Which one is correct? Can you guess which one is correct? $17.1 multiplied by 10 to the million is what? Million is 6. 10 to the 6 is million. Okay. How do you 1.7? 17.7. This is not right. I'm not writing. Oh, I can erase that. I didn't know. Okay. 17.1. Million is, how many zeros million has? 6 zeros. So this is this number. This number here is that number. Now, how do you write it in scientific notation? You have to move the decimal place to right here. From here to here. One place to the left. So if you move one place to the left, it becomes, if you move one place to the left, it becomes -1. If you move positive 1, I'm sorry, it's positive 1. Six plus 1 is 7. So answer is 1.7, 10 to the 7. Did you see how I got it? Do you have any questions? I wrote down this number, million here, 1.17.1. Then move the decimal place here. If you move the decimal place, you add up exponent. If you move to the right side decimal place, you subtract or -1. Okay, 10 to the -1. Is it clear? Okay, let's look at this problem. During its orbit, the Earth minimum distance from the Sun is this, kilometers. Which of the following represent the number in scientific notation? So we have to convert it to scientific notation. Just like what we did before. 148 multiplied by million. Million is 10 to the 6. How many of you know million? Million is 1 times 10 to the 6. That's why 10 to the 6 here. Now you had this number 148, that's multiplication sign. The decimal place has to be moved to the left, right here, after 1. So if you move to the left, you add one exponent for each movement. So in here, you move twice. Therefore, that 1.84 10 to the 6 2. So it becomes 1.48 10 to the negative 10 to the 8. So which is the correct answer? D. Okay. Do you guys agree with me, or you have any questions? That's the correct answer. In 1 second, light travels this many number 10 to the 8 meters. In the conventional notation, how do you write this in conventional notation? So you have to move decimal place. How far? Decimal place to the right. You have to move decimal place to the right here. So it is 10 to the negative 2. So 10 to the negative 2 is 10 to the 8 negative 2 is 10 to the 6. 8 minus 2. So there should be how many zeros in front of this number? Then you convert this number to the following way to write this in conventional notation. So 6. Do you see this one is the correct answer? Their decimal place is moved 6 places. Decimal place was here. 1, 2, 3, 4, 5, 6, 7, 8. No. This is the large number. That's why I picked that one. So 10 to the 8 minus 2. I'm messing it up. 2.998. 10 to the, I'm making it more difficult. So in this number, you have to move decimal place to the 8 places. 1, 2, 3, 3, 4, 5, 6, 7, 8. There are five zeros. That's the answer. 5 zeros after decimal place. Yeah. The correct answer is C. Do you see how I got it? Do you have any questions? Do you have questions? The population of Earth at the end of the 2018 was approximately this. Which of the following is representing this number? Correct way to represent this number. That's the normal number. How many zeros you have to have? 8 zeros after 77. So 8 zeros is right here. 1 to here, then 8 more. So answer is A. Did you get that one? This is simple questions. The surface area of Earth is approximately 1.48 10 to the which of the conventional notation. How many zeros? This is a large number. So 1 to 6 zeros after. 6 zeros after 149. Why 6 zeros? You move here. 2 already gone. 2 minus 8 minus 2 is 6. Therefore 6 zeros after 149. Which one has the 6 zeros? That one. Therefore correct answer is B. Do you see that? Sometimes the same word can have different meanings. In US, million means, I said million is 1 times 10 to the 6. Remember I said that? So in means million, a million. Okay, I need to. I cannot see this one. Okay, 1,000 million is a billion. 1,000 is 10 to the 3. Therefore, in US, billion means 1 times 10 to the 9 US. But in British, million is 10 to the 6 times 10 to the 6. That becomes 12. So which of the following is British billion? 10 to the 12. That's the answer is B. Reporting numbers in scientific notation. For this number, meters of length, conventional notation. So you see that conventional notation, this has to be moved to a 1.0, 10 to the something. Then you move to the left. Then you move to the right. That means 10 to the negative 1 place. Into the negative 9. Therefore, answer should be when you move the decimal place 1 times 10 to the negative 9 is 10 becomes negative 9. So let's look at the choices. Those are, oh, okay. So what you have to have 9 zeros. This means 1 with 9 zeros. Three here, 3 here. That's 10. 3 here, 3 here. So this is the correct answer, because you had to move 1 here. This become 1 and 8, 9, 8 zeros here. 8 zeros. The 1 is this is the correct answer. So you figure out, oh, that's, let me go back and redo it. I may have made a mistake. Okay. Conventional notation. How many decimal places you had to move here? Decimal place here, 1. 10 places. 5, 5, 10. That's the way to go. You have this 0.1. This has to be moved 10 times. If you get here 1 is gone, then 9 times means 8. So 8, 5. Okay, I'm not saying it right. When you move decimal place, ten times this way. Let me write down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a 1 0 here, 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 1 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 decimal place is here now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the correct answer. Do you understand that? How I come up with? Which is the largest number among the following? When you have scientific notation, you look at the exponent first. The highest exponent is the largest number. In this case, highest exponent is 10 to the 4. So therefore, answer is B. Which is the smallest number? That this is the other way around. Smallest number is the highest negative. That's the one. Now, smallest number is a negative, highest negative number. We normally don't worry about these first places in that case. So answer is D. Okay, this is easy one. When you move decimal place, 1, 2, 3 is 10 to the negative 3. So you write down 3.58880. That's the answer. So let's see whether we have the answer. So answer is C. All right. Which number is the largest number? They are all numbers are equal. Then the largest number is largest exponent. Therefore, A is the answer. These are the 6 base units in the metric system. They are meters, liters, grams, seconds, Kelvin, and moles. There are other systems of units, CGS system, where centimeter, grams, seconds are used. The common system, day-to-day use, we use pounds, gallons, etc., and Fahrenheit. Okay, when you look at unit part of the measurement, it could be abbreviated or expanded. A small number in the measurement with a lot of zeros in the decimal place. So we can use kilograms or micrograms rather than just using grams. So this is scientific notation applied to unit system. So we go on over this little bit. Okay, that's where we stopped last time. How many of you remember we were there last time? Can you guys hear me?
Yes.
All right. I'm just checking whether my mic is working. Okay. If you have a measurement, which is important in scientific method, it has number part and the unit part. Now we're going to look into a unit part, a number part, and show how we round off, how we tell significant numbers, significant figures in the measurement. First one, if you have a number with no zeros, all numbers are significant. 233.1. All 4 numbers, the last number to the right is the uncertain digit. Uncertain digit is 1. You count all the digits, numbers, starting from uncertain digit to the left. 1, 2, 3, 4. So this number 233.1 has 4 significant figures. Pretty easy to find out significant figures when there's no zeros. Zeros complicate. We're going to look into how we do it when there's zeros. 2.3 has 2 significant digits. Starting with 3, there are 2 numbers. 3 in the 2.3, right most number is 3, which is the uncertain digit. So we normally, in a measurement, we round off it to the uncertain digit. So measurements are just not all the numbers. Only we write down significant numbers, which are important. Okay, about the zero, when there are zeros, in leading zeros, zeros at the beginning is called leading zeros. Now, paragraph 2. For example, 0.0055. The leading zeros are not significant. Any leading zeros in a number is not significant. Do you understand? It's a whole number. We don't write zeros. In decimal numbers, we have to use numbers to show the zeros, to show the placement of decimal point. Okay, leading zeros are not significant. You understand that? Paragraph 3. 0 at the end of number, which are called trailing zeros. In a whole number, trailing zeros are not significant. But in a decimal number with decimal points, zeros are significant. For example, 3.00, 2 zeros at the end are significant. Therefore, both zeros count for the significant figure. Therefore, 3 significant figures. On the second example, 0.0450, the beginning two are leading zeros. They are not significant. But the last one on the right, after 45, is in the decimal place. Trailing zeros in the decimal place. Therefore, it's significant. Therefore, 3 significant digits. So zeros at the end of the number that contain no decimal place may or may not be significant. So, for example, $36,000. There are 3 zeros. Is ambiguous. Therefore, we normally consider as 2 significant figures. If all zeros are significant, you have to put a decimal point at the end of the number to make all 5 numbers significant. Okay, if you take 5.00 milliliters, only 5,000 milliliters. That's a comma after 5. So only first number is significant. Therefore, it contains 1 significant figure. But to make all the significant numbers significant, you have to put a decimal point after 500 decimal point. That makes it significant figures. Now you got some idea about how we figure out significant figures on given numbers. Any number, with some with the trailing zeros, leading zeros, some with decimal points. Okay. Do you have any questions about this?
No, sir.
All right. If you have, we can talk about it later. Okay. Now I have to tell you about certain numbers which don't have significant figures. They're exact numbers. For example, if a number comes out of a definition, 1 dozen is 12 is equal to 12. 1 dozen is equal to 12. 1 egg is equal to 12 eggs. That's a dozen of eggs. So those numbers 1 and 12 are exact. There's no significant figures in them. So when we use them in calculations later, we don't look at their significant figures. All right? I'm going to bring that point later. What is the exact number? Exact number is one found in unit conversion factors. That comes from a definition. 1 centimeter is equal to 15.3 centimeters, or exact number results from measurement of observation and contain some uncertainty. Okay, we are going to talk about what exact numbers don't have significant figures. Okay, can you remember that? Exact numbers which are found in conversion factors don't have significant figures. We're going to go through some examples again. First number, 65.2. There are 3 significant figures. Why? You count the 2, that's the uncertain digit, and count from right end to the left, 1, 2, 3 figures. The next number, 255.345. has 6 significant digits. Do you see rightmost 5 is the first one, then you count to the left, 1, 2, 3, 4, 5. 5 digits, 6 digits. Okay, that's how you tell the significant figure. Okay, these are examples of that I tried to explain in a previous slide. In 0.00245, how many significant digits are there? The zeros are at the beginning are called leading zeros. They are not significant. Therefore, you don't count them. Therefore, 5, 4, 2, only 3 count for 3 significant figures. The next problem, 0.008. Leading zeros are not in the decimal place, are not significant. Leading zeros in whole number also not significant. We don't write zeros in front of 200. You don't ever write. So that's, you also already know not to write. But in decimal places, you have to keep the place value with zeros. Okay, third one, 2,570. So normally that 0 at the end of a whole number is not significant. Therefore, it's 3 significant figures there. If you want to make that 0 significant, you have to put a decimal place after 0. If I had 0 after this decimal place here, decimal point there after 0, it becomes 4. But none of these have. Okay, this is the whole number. These 2 zeros are not significant. Therefore, it's only 5 significant digits. Do you have any questions about it?